If you are using Google Maps, you probably don't want just to have an empty map, right? You want to draw something on a map. And today we will cover 4 different types of components that you can draw on the map. They are markers, clusters, shapes, and overlays. We will mostly focus on markers and clusters because it's what we usually use more. And we will slightly cover shapes and overlays, so you just have an overview on those ones as well. So starting by the markers. Good afternoon, everyone. First of all, thank you for being here, watching my session about mapping the future, implementing Google Maps on Android with Jetpack Compose. I am Fabio. I am an Android engineer for 12 years now. And the agenda for today, it's basically go from zero to production with Google Maps. So we will cover the basics, and in the end I will show you what we have done, me and my team at Volvo a few months ago, with Google Maps in a production application. So before we start, how many of you by hands have used Google Maps before? All right, half of the audience at least. And how many of you have used Google Maps without Jetpack Compose, so using XML views? Yeah, pretty much the same. So we have some of the old people in here. So if you have used Google Maps before Jetpack Compose, you're probably used to something like this. So you would have to go and configure your API key, and of course, this is probably still it's probably the only thing that it's still the same. You would need to configure your fragment and import a support map fragment and set up your activity. And after that, you would need to go into your activity, import the view, call the get map async to start the map loading, and of course implement the onReady callback and the onMarker click listener, so you could be notified once your map was ready to use and when each of your markers were clicked. After this, you would need to go and override the onMapReady function. And inside this onMapReady function, you would have to set up your click listeners, you'd have to set up your markers, you'd have to set up your animations. So pretty much everything that you would do regarding your map usage would be done inside of this function. And after this, you would still need to override the onMarkerClick function. Try to figure out which marker was clicked, probably by setting up some tags on the markers when you are converting your data set into markers, and then when the SDK gives you the marker, you will try to figure out which marker was clicked by using that tag. So, although we didn't knew Jetpack Compose yet, we probably could assume that there should be a better way of doing maps, and the better way, in my opinion, came with Jetpack Compose. So nowadays, in order to set up a very simple map, you just need to set up your coordinates, set up your camera state, and basically call the Google Map composable and pass it some marker. So pretty simple, right? Just with like 10 lines of code, I have a map, I have a marker, and if I click the marker, I still have the default info window for that marker. So pretty amazing. For me, it's magic. I love it. Let's see how we can go from zero and configure the Google Map and take it into production. So the first part is import the dependency. So it's set up our API key and import the Maps Compose dependency. I think this is the latest version. And after that, you set up your regular Jetpack Compose activity, you set up your theme, your scaffold, and you just call the Google Map Composable. And just by that, just with a single line of code, you have your empty map drawing on the screen. But of course, if you are using Google Maps, you actually, before that, let's take a look at the Google Map Composable. So Google Map Composable takes pretty much the entire configuration of the Google Map. It is a lot of parameters, but the 3 most important parameters are probably camera position state, which allows you to move the camera around, properties, which allow you to set up the properties of the map, and UI settings, which allow you to enable and disable some stuff on the map. So taking a closer look on those classes, Map UI settings basically allows you to, for instance, enable or disable zoom controls, zoom gestures, and the location button, if it's enabled or not. Map properties allows you to enable, for instance, to set up the min zoom or the max zoom, the map style. You can, for instance, import a different map style for your Google Maps and make it look more alike with your application. Or, for instance, enable or disable your location on the map. So if your point is being drawn on the map by just changing this flag. The other parameter was the camera position state, and camera position state basically allows you to configure the point of view from the user to the map. So you can configure the center of the map, you can move the map instantly, you can animate the map, basically running some code like this. Okay, of course, important to note that all of the animations need to run into a launched effect or some suspended function. But these are probably the three more important configurations of a map. And the way to pass them to the map, of course, it's just normally using the parameters. I just wanted to point this slide out because if you notice, I am using a map UI settings a plain object, not a state of a UI settings, but I am using a mutable state of properties. And this is because you need to start the location property as disabled and ask for a runtime permission for the location permission, and only after that you can enable that property. So I'm using a state, so I can later enable the property and show my location on the map. All right, but if you are using Google Maps, you probably don't want just to have an empty map, right? You want to draw something on a map. And today we will cover 4 different types of components that you can draw on the map. They are markers, clusters, shapes, and overlays. We will mostly focus on markers and clusters because it's what we usually use more. And we will slightly cover shapes and overlays, so you just have an overview on those ones as well. So starting by the markers, these are the marker composables that are given to you. So there are 2 different marker composables, and if you take a closer look on them, they are pretty much the same with just a simple difference, which is the last parameter. So the marker info window, the one on your right, is taking a content as a parameter, and you basically can configure not only your marker, but also pass a customized component to your info window. Apart from that, you can also configure some other parameters, like, for instance, the title, the snippet, the visibility, the Z position of the marker. All of that can be configured here on the marker composable. So basically, the way of using your markers is just calling your Google Map composable and pass a marker inside of that composable, and just like that you have a marker drawn in the positions 0, 0 of the map, which is great, right? We just used 2 single lines of code and we already have a marker and a map and a marker. But of course, probably you don't want to have your marker on the 0, 0 coordinates of the world. You want to position them somewhere. So if you want to move them to, for instance, one of the most beautiful countries in the world, you can put your center coordinates in Lisbon, which is the capital of Portugal. And the way of changing the marker state into Lisbon is basically just set up your lat long coordinates, remember the marker state, this is a Jetpack Compose function, and pass that state into your marker. So it can't really get any simpler than this, right? But then, if you define a title and a snippet, you also have access to the default info window of your marker. So just out of the box, you have this info window right there with whatever you want to put inside, right? And that's amazing, but there are a lot of other stuff that you can play around with the marker. You can, of course, set up your click listeners, both for the info window and for the marker itself. And you can also, for instance, assign an offset to your info window. So in this case, the info window moves to a different position from your marker. It can be useful if you want to put it on the left or on the right or customize it somehow. In this case, I am just moving it 2 degrees north. And of course, if your marker, like some of us, had just a little bit too much to drink like now and is looking like a drunk marker, you can just assign it a different alpha, a 50% alpha in this case, and a 45 degrees rotation. And just like that, you have like a drunk marker on your screen. And if after that is feeling a little bit blue, you can just change the icon of the marker just by assigning the same default marker that it is using and changing the color of the marker, which is great, right? With just small configurations, you can configure your markers and make them look more like what you want, but probably you don't want to use a single marker. You want to use a data set and draw a list of markers on the screen. So in this case, we are using a data set of 25 Portuguese cities. I asked AI to generate the coordinates, so if any of this is wrong, it's not my fault. But just remember, the array has 25 cities, and the way of drawing this array of markers in your map, it's again as simple as it can be. Just using a for each, go through your array of lat-long coordinates and call the marker instance. Okay, amazing. 3 lines of code. If you remove the parentheses, and you already have a map, your markers, and your dataset being shown on the map. But after that, you probably want to customize your markers, right? And you probably want to tweak a bit the camera so the camera moves into your markers, and it's not like this where you have the camera pointing in the center of the map while the markers are in Portugal. And the way to do that, it's pretty simple again. So the way to change the camera, of course, it's creating a camera position from lat long. This is all given to you. You just provide the coordinates of the center of the map and the zoom level. You call the remember camera position state, and you assign the position. And after that, passing the camera position to your Google map will move the map into Portugal, okay? And changing your marker icons again is just using a bitmap descriptor function. This function is not a Jetpack Compose one. So what we did was basically use a function from the web to load a drawable into a bitmap descriptor. It's not important for this scenario. And just like that, your markers are customized. You have beautiful markers on your map, again, with just a few more lines of code, which is amazing. But probably after that, you want to distinguish some markers, right? You don't want to have all of your markers showing the same image. And the way of doing that is just identify the markers that you want to change and use a different marker call for those markers. In this case, the only line of code that is changing is in the marker is the icon that we are using, which in this case is drawing this marker over here. If you could not see it well, and probably you couldn't, because it is being drawn behind of other map markers. And the way of bringing it forward, it's by using this z-index parameter that basically allows you to move markers in front of each other. So by default, the markers are created with the z-index on 0. So you can assign different z-indexes to all of your markers and basically decide which of the markers are to be drawn on front and which of them are to be drawn on the backwards. Perfect, right? So after this, you probably want to configure your info window, and although the default one looked a lot better than this, you can do it. And if you remember correctly, in the beginning I said you have to use a different composable for that. That composable is the marker info window composable, which basically works exactly in the same way. It just takes a random composable. In this case, I passed a column and a text, and we have this very, very ugly design. But again, if you want to make it prettier, you just ask AI to generate some random code for your info window, and just like that, again, with just a few lines of code, of course, if you remove this big composable that you probably can't read, you have a beautiful info window for your markers. Can't be easier, right? But after this, you end up with a bunch of markers that are not clustered, right? If you zoom in or zoom out the map, you will probably not have the greatest experience, and especially if you zoom out, all of your markers will probably be on top of each other, which is kind of a weird experience. So let's jump into clusters, okay? And in order to use clusters, we need to implement a different dependency, which is this second dependency, maps compose utils, which basically gives you access to these two composables. And these two clustering composables allow you to do everything that you need to do with clustering, sorry. The one on the left takes a lot more parameters. As you can see, you can configure, for instance, the cluster content, the cluster item content. You can configure the clicks of your clusters or the clicks of your items. And the one on the right basically just takes two parameters, which is the collection and the cluster manager. But spoiler alert, you can do exactly the same that you are doing on the left, on the one on the right, by just passing the same parameters to the cluster manager, which is great, right? But if you also notice, instead of having a collection of lat-longs, we now have a collection of cluster items, which it's also a change regarding to markers, because now if you want to use clustering, you need to convert your dataset of lat-longs into a dataset of cluster items. So what is a cluster item, you might ask? A cluster item is just an interface that takes position, title, snippet, and z-index, and basically takes the same coordinates that our markers did in a different interface. And the way to create this is just extending, or implementing in this case, the cluster item interface, and pass it the position, the title, and the snippet, and basically assign it to the overridden functions. In order to use clustering, you just take your Google Map instance, like the one that we were using before, and instead of adding a marker, you are now adding a clustering function, and you basically need to map your Portugal cities array of lat-longs into city cluster items. In this case, I am just passing them the lat-longs and passing empty for the title and the snippet. But as you can see, we have a perfectly functional clustering map now. And again, with what? 5-6 lines of code? It's amazing, right? Of course, our markers are, again, the default markers. We will see that in a minute. So if you want to customize your markers back, you can again use the big clustering function and basically pass the cluster item content and the cluster content to that function. In this case, I am passing an icon because it's important to notice that cluster item content doesn't accept a marker, it takes an icon. So you can pass an icon and just customize your marker, and basically this cluster item is this icon in here, so it's basically your marker content, and you can also pass a different or a customized cluster content. In this case, I am passing a surface, a box, and I am drawing this black circle with the number of clustered items inside. So all of this is customizable. You can do whatever you want. In this case, we are just making it black and with the size of the cluster, and just like this. And of course, you can do exactly the same thing with the other clustering function, as I said before. So instead of passing all of that to the clustering, you will be passing all of the information to a cluster manager. And the way of doing that is by creating the cluster manager using this remember cluster manager function. You can pass it your city cluster items. You need to check if it is null or not, and after that you can create a renderer by just using the remember cluster function, the remember cluster renderer function, and pass it the cluster manager, the content, and the item content as we did in the other clustering composable. So let me just hydrate a bit. You can see that in here we are using a side effect to assign the renderer to the manager, and this is very important because if you don't use a side effect, you will have an illegal state exception. And of course, your build will fail. But other than that, you just need to map your items and pass the items and the cluster manager into the clustering function, and you have exactly the same result. So why are you showing this, right, Fabio? We will get to that in a minute, but before that, let's check how does this behave, okay? So what's the performance of our map? We can see that we have a data set with 25 markers being clustered, and we can zoom in and out of the map, and it works perfectly fine, right? No big issues in here. But what happens if instead of using 25 markers of 25 Portuguese cities, we ask AI to generate a list of the parishes of 9 cities in Portugal? In this list, we have 133 items, so we are increasing our dataset by a factor of around 5. We are not adding like 1,000 markers, we are adding 133 markers to our map. And if I push back the animation just a bit, we can see that when I am zooming in the map, it starts lagging a bit. You see that I zoom in and it takes 1 second or 2 seconds before it expands the clusters, which is pretty weird, right? Just 133 markers. And this happens because by default we are using a non-hierarchical distance-based algorithm, which the SDK sets up for you. And this basically allows you to, this basically says that your markers will always being drawn on the screen. So it doesn't matter if you are looking on a small portion of the screen, all of your markers will be being drawn on the screen at a certain point in time. So even when you zoom in to expand just a few markers around Lisbon, your marker is expanding all of the clusters on the rest of the map. And this, of course, it's not very good in terms of performance. So Google gives you out of the box a second algorithm, which is called non-hierarchical view-based algorithm. I will just call them distance-based and view-based from now on for language sake. But if you take a closer look, you can see that basically the view-based one is just an extension of the distance-based one. And this is basically because the only difference that the view-based shows off is that it only draws the marker that are visible in a certain portion of your screen. So you can pass it the width and the height of your screen, and it will only draw the markers that are visible inside that area. Okay, and the way of adding up the markers to your I think I have a bigger image. No, this is the biggest one. If anybody can't read this, I can just zoom in, but I will point up the differences and see that in here we are explicitly declaring the exact same algorithm that it is used by default, just so you can see, and we are using a distance-based algorithm with a max distance between cluster items of 100, and the way of passing up that algorithm to your Google Map is just by changing the algorithm parameter on your manager, and you are basically switching the algorithm to a different algorithm. So here on the right you can see that I am setting up a view-based algorithm by fetching the screen configurations and getting the height and the width, passing them to a view-based algorithm and passing that algorithm to the cluster manager. And just like that, let me just zoom out. This is the exact code of the view-based algorithm. If you didn't have enough time to see it, just like that, if I zoom in on the map, you can see that our markers just get much more fluid. We can zoom in and out of the map, and it doesn't take any more 2 seconds because it is only drawing these around 30 markers that we have around Lisbon instead of drawing the entire 133 markers of our data set. Pretty neat, right? So why don't we always use this algorithm instead of the other? For me, I don't use it because I particularly hate this behavior, which is after that, if you start moving the map to the side or to the left or to the right, you of course will see that some markers will start showing and disappear. And your clusters will change of size because some of the items that were being grouped in a different cluster are now being grouped in another cluster. So if you are picky enough, yeah, this probably will affect you, and you will prefer to use a distance-based one. But yeah, not much that you can do. All right, so as I said, we don't have much time to cover shapes and overlays, but just to give you a very quick overview of what you can do with shapes, there are three types of shapes: circles, polygons, and polylines. And the way of configuring them, this is the circle composable, is just by setting up a center coordinate. Setting up a radius, for instance. You can of course configure your the colors of the circle. You can configure the stroke of the circle. You can, for instance, use a dashed line or a full line. You can pretty much do whatever you want with it, and just by calling it in the same way that you would be calling your markers or your clusters, you have a circle drawn in the center of Lisbon. Okay. For the polygons, it is a bit different, but polygons and polylines behaves more or less in the same way. Instead of passing the center coordinates, of course, you need to pass a list of points, and then you can also configure your stroke if you want, or if you need to, you can also pass a list of holes that basically will be drawn inside of your polygon. All right, so the way to use this is, of course, set up your data set of points, a list of lat longs in this case, and pass it to your polygon composable, and you have that drawn on your screen. In this case, it's important to notice that the order of your data set matters, because if you, for instance, change the last item of your data set, in this case it's Benfica, to the second position of the data set, you have a totally different polygon. So important to notice, the order matters, okay? And for the polylines, it's pretty much the same. So it's the same in terms of implementation, and it takes very few different parameters. In this case, it's the start cap and the end cap, which are basically ways of configuring your starting point and the end point of your polyline. And of course, instead of having a polygon, you have just the lines of that polygon. Important to notice that on the polygons, if you don't pass an end, if you don't need to close the polygon, you can just pass individual points and it will close it automatically by connecting the two closer points. On the polylines, if you don't do that, the points are not put together. Okay, and overlays basically are a way of putting some images on top of your map. This can be particularly interesting, for instance, for drawing weather apps, so suns or clouds on top of certain regions of your map. I am not pretty much covering that, but we have ground and tile overlays, and the way of using a regular overlay is again the same as markers, clusters, and circles or polygons, which is basically calling the type of overlay that you want, pass it a drawable, again with a bitmap descriptor conversion, and set up in this case the ground position of your overlay. Okay, so you are basically passing the lat long coordinates of that overlay with a certain width, I think in meters, and it draws this image on the screen. You can see that while we zoom in, the image doesn't, in this case, doesn't resize, like for instance the markers. So it will end in some ugly shape like this. So our idea is to take you from zero to production. So as I said, I have worked for Volvo for 3 years, and I left Volvo a couple of months ago, so I couldn't use the official application, but I had tried to replicate as much as I could the code that we are using that, so you could see what we were doing in production. And basically, we were using custom markers, custom clusters. We were enabling the My Location marker as well, and we had filters that would allow us to animate the map in moving into our current location or into the car location. which is pretty much what I am showing here. So we will take a look, aside from the map configuration and the simple stuff, how can we call these animations and slightly tweak your map so it gets a little bit more beauty or performant or wherever you want, basically. So the first step is, of course, configuring the Google Map, and in this case we are pretty much disabling all of the UI settings because we want to fully customize the map, and also because most of the components would be showing on your inferior right corner where we are putting these permanent bottom sheets, so they wouldn't be visible. We are passing the map properties with isMyLocationEnabled as false in the beginning, and we are doing it this way because we need to ask for the location permission, so later we can enable this functionality. And we are using a parameter of the Google Map that allows us to know once the map is ready to use. So when it is ready to use, we are basically creating two different types of markers. One of them is not being clustered, which is the vehicle marker, and the other one is being and the other ones are being clustered inside this clustering items function that I will now show you. So basically we were just using the exact same configuration that I showed you before, using a view-based algorithm. Okay, so we were fetching the screen configurations, we were passing it to the cluster manager, and we were preparing the renderer with our custom markers and the custom clusters, pretty much the same that we did before. And we are basically using side effects to understand when a marker was when a cluster in this case was clicked or not, because we wanted to override the function of the cluster items instead of just center the map on that cluster to zoom in into that cluster every time that you click on that cluster. You can do that by just tweaking a bit the camera position state and pass it a camera update factory with calling the function to zoom in, and just like that it will zoom in into your clusters. And of course, if you reach the point where your cluster needs to expand, it will automatically expand. And here in the end, we are assigning the cluster manager, the cluster renderer into the manager, and of course instantiating the clustering composable by passing our dataset and our cluster manager. For the other marker, it was a very plain marker. It was using a default icon. We were setting up the z-index so it should always on front of the other clustered markers. And we're only drawing it if we have the vehicle coordinates available. So after this initial configuration, you need to set up some launched effects. This first one is basically to enable the My Location. So as I said before, after we asked for the location permissions, you can use this launched effect to observe a regular mutable state flow. And after we have location permission, just update the map properties on the map, and suddenly we have our current location on the map, which is perfect, very simple. The second use case that I want to display here, it's basically a way of updating your dataset by filtering only the items that are visible on the screen. So you can see that we had this bottom sheet here on the screen that it's basically updating all of the current retailers according with the retailers that are visible on the map. So when we zoom in on the map, it is basically also filtering the retailers from the bottom sheet. And the way of doing that is by using a launched effect. In our case, we were always checking if the map is moving or not, and you can do that by just checking the isMoving parameter from the camera position state. And when the camera was not moving, we were basically checking the reason of the past movement, checking if it was a gesture and not, for instance, a click on the zoom controls or something like that. It's just a double check because we disabled the zoom controls in this case, and fetching the visible region from the camera position state projection and passing it into a function into our view model that basically would filter the dataset by position of that projection. The third use case that I want to show you is how we were searching for a location, clicking on a retailer that would show up in the search, and just moving the map into that new position. So basically, of course, we were using a different API to fetch the coordinates of the search. After we get that lat long, we just need to call the camera update factory with the new camera position, pass it the new center coordinates for your map, and if you use animate instead of move, it will do this slide animation with a default duration that you can set up here within this parameter, duration milliseconds, and it will move from the point that it was until your new center. Pretty amazing. Just with a few lines of code you can customize your animations. And the last one is moving the map to the coordinates of your car or to your user coordinates. In this case, we are basically just observing which filter was clicked by the user in a launch defect, and would be basically moving the camera using the exactly the same animation that we used before to move the camera both either into our current position or to the car position. And I think this is my last slide. This is just a zoom in of the code. So thank you very much for watching these sessions. You have my contacts over there. You have my LinkedIn using this QR code. So if you want, just add me. And if we have time, I'm available for some questions. Thank you.